Okay, this segment is going to be about the Class 2 harness. So a Class 2 NFPA approved harness meets the weight requirements for a design load of 600 pounds, but it is a seat harness only. So we're not going to see a chest or torso attachment to this harness. In this application, Scott wearing the Class 2, he's using the CMC Pro Series harness. One of the key components that we want to focus on beyond just fit are the additional pieces of gear or equipment or rigging elements that he's integrated into the harness. So let's start with the harness. As we look at the harness, when we don this harness, we want to make sure that we approve appropriate sizing, whether it's small, regular, or large. When we look at those sizing configurations, they all cross-reference to a general waist size. We want to make sure that that harness falls within the parameters of what our waist size is. As we pull down on the two waist cinching straps, those elements, when drawn in, will bring that waist configuration in tighter and tighter. We want to try and ensure that the fit of that waist strap, which is the first element that we cinch down, rides on our hip bones. If we get it above the structural portion of our body on bone and we get to the fleshier soft areas of our upper torso, that waist belt will cinch down and cause significant pain to the kidney area. So make sure that that is fit right about where you would normally wear your belt. We want to ensure once we've cinched that down that we mind those straps, fold them back up a little bit so they don't become entanglement hazards, and then use the Velcro enclosures to go ahead and keep those out of our way. Then we're going to work on our leg straps. If you look at the leg straps, you'll notice that there's two buckle and buckle configurations on the front of the leg stirrups. Those can be easily detached by simply pulling a little bit of slack in one of them and then articulating the inner or smaller buckle and allowing it to navigate back through the slotted openings of the larger buckle. So when we configure these, we can keep those disassembled, get the waist belt on quickly, then go ahead and drop in the small buckle into the larger buckle, ensuring that those straps are straight, clean, and neat. And then we're able to articulate that buckle out at about a 90 and then glide down or cinch down our straps to our leg components. When cinching down any of these elements to ensure that you have a proper fit and that you have appropriately drawn those straps down to the correct tautness, you want to take two fingers side by side and insert those fingers laterally between the strap and whatever portion of your body they're going around. If you can fit two fingers in there and no more, then it's drawn down appropriately. So that's a good field test to make sure that you've snugged down your harness to an appropriate dimension. As we look at the posterior or rear portion of Scott's Class 2 harness, you'll notice that there are two rear straps that are going to adjust the vertical fit of his leg stirrups in relation to his waist strap. These will consistently loosen up while you're working on the rope ground. And when you get ready to go over the edge, it's important that you bend over at about a 45-degree plane before you cinch those down. You want to be in about the natural resting body position that you're going to be in while you're on rope. If you cinch those down while you're standing fully upright, when you go to get on rope and try to bend your legs, it's going to pull your waist strap down and put a lot of back tension on the back of the harness. So ensure you put your body in the right body position when cinching those down. Now we're going to talk about the equipment options or the attachment points that we're going to utilize for the Class 2 harness applications. So we're going to start by looking at the front primary rigging component on Scott's harness. With all harnesses, manufacturer recommendations are that we don't make subsequent or alternative attachment points to the harnesses. At all times, utilize the engineered, designed, and tested rigging component for your primary attachment points that will go to any element in the rope system that can or will be potentially loaded. If you notice, Scott has elected to use a screw link. Ensure that your screw link has an appropriate design load and then configure that into your brake bar rack. If utilizing a seat harness or Class 2 harness with a laterally oriented rigging component, which means parallel to ground, it's important to utilize a twisted eye brake bar rack. By utilizing a twisted eye brake bar rack, when that rack is loaded the way it's going to be on rope, we'll notice that the nut of the rack or the nut on the frame of the rack is oriented to the downside of the brake bar rack. If you utilize a twisted eye rack in this configuration, when you are adjusting friction on the bars of your rack to manipulate how quickly or how slowly you're descending down rope, that allows you to pass rope back freely from hand to hand without ever having to bring the rope up over your body and incur potential entanglements. So it's imperative when utilizing that type of attachment point on a harness that we utilize twisted eye racks. The screw link is another important component. There is a lot of legitimate theory and testing and data collection out there to validate the fact that utilizing locking carabiners in a threaded gate application, when those carabiners are oriented to the brake bar racks, there is always a possibility of those carabiners becoming unloaded, either by contact with the rescuer himself, contact with the victim or wall surface, or simple gravity if that gate is not fully locked. Fully locking screw links ensures a better performance of safety, as well as any potential side loading. If that brake bar rack ever at any point becomes unloaded because Scott stands up on a rock or any other components like that, there's a lot less critical failure of a screw link application than there is of a carabiner if that piece of hardware becomes gate loaded or loaded incorrectly.